So today we are joined by Will and James from Arup. James is a tunnel engineer in Arup's Midlands campus office, originally with a background in bridges and civil structure design assessment before transitioning over to tunneling. He has a relatively wide experience base formed through many projects within major infrastructure remit with clients such as Network Rail, High West England, High Speed 2, and so on. And of course, utilities as well, with clients ranging from Cajun Gas, Scottish Power to National Grid. His experience covered every design stage from feasibility through to operational maintenance. He has a keen interest in emerging technologies and utilizes digital techniques in the form of both inspection and design. Will is a senior tunneling engineer working from Arup in the Midlands office as well. Will started working for Morgan Sindall on Crossrail in 2012 for the assessment for asset management and inspection for ground movement assessment. This led Will to undertake research on the use of drones for monitoring assets using photogrammetry and change detection. In 2014, Will joined Arup's tunneling and geotechnics team, where he specialized in trenchless technology, asset management, inspection works, and rehabilitation of tunnels. Will is a chartered engineer with ICE and a fellow of the Geological Society. Will works on trenchless tunneling and inspection projects globally and is global microtunneling microskill leader as a part of Arup's global tunnel skill network, bringing quality and lessons learned to projects around the world. I must also add, Will has had a history with BTSYM himself. He has previously served within our schools and universities subcommittee and moved forward to become the secretary of BTSYM. So it gives me immense pleasure to welcome Will as a speaker today. So without much ado, the stage is all yours, Will and James.
Thanks, Divik. Thanks for hanging over. Apologies if you hear any background noises. All of my neighbours seem to have started the 5th of November celebrations in earnest, so apologies if you hear anything. So as Divik has stated, my name is James Connell, and I'm joined by my colleague Will Howlett, both from the Midlands campus office. We form part of the Bridges, Civil Structures and Tunnels team in this office, and we generally lead the tunnelling works from within. We complete a lot of confined space work, and we complete a lot of condition and structural assessment of tunnels of all sorts of shapes and sizes. And today we're just going to present some food for thought on digital inspections and how they might help you and your clients. We'll also cover a few watch-its along the way as well to help you out. So a quick agenda then. I'm going to hand straight over to Will, who's going to take you through the first few bullet points. So first of all, what makes a good inspector? And then we'll cover some confined space regulations and also some client requirements for some specifics. He'll then talk about a risk balance between confined space entry and not. I'll then take over and cover some conventional inspection methods and some new innovative digital inspection methods. We'll look at 2 case studies, the first one being London Power Tunnels decommissioning project, and the second one being Queen Alexandra Hospital steam duct study. And then I'll hand back over to Will to explain what's next, and we'll cover any questions you may have. So, Will, over to you first.
Thanks, James. So I thought it was important to actually go over what makes a good inspector. And the reason for going over this is it will become apparent on some of the digital techniques James is going to speak on, why we decided to develop them. And if we look at what makes a good inspector, I've made a list of some skills. You've got structural knowledge. This isn't analysis, this is kind of structural behavior. Geotechnical knowledge, concrete specialist, reinforcement specialist, corrosion specialist, defect specialist, fungus specialist, desk study champion, I've called it, trying to pull together all the existing information which is in clients' records, the internet, in order to understand the asset, and also being a good author, being able to write down what you have seen and what it means to the client and other people. And all of this is not possible by one person. And when you're planning to do an inspection, it's impossible and it's not cost effective to bring all these people with you. So what usually happens is a smaller group of people go in who have general specialisms or maybe 1 or 2 of these niche skills to inspect the asset. And when they come across a defect or fungus, for example, they have to then come back to the office and try and find a specialist. And within their company, most consultants will have specialists with all these areas, but they may be in Canada, Australia, and so on. And so some of the ideas on the digital side was, how do we therefore bring those people into the tunnel? So we didn't bring them with us on day one, but how do we therefore bring them to the tunnel in the future? Which is kind of where the virtual reality comes in. The traditional looking at a report and you get asked a question, or do you have a photo looking in the other direction? When you say no, so where 360 imagery started becoming useful. And there's some quite interesting areas for this. So for fungus being one, so we're inspecting tunnels for Severn Trent water, and we'd never thought a fungus specialist would be important. But about 50 meters deep in a tunnel, we found this golden fleece, is what Severn Trent water called it, and it was about 30 meters long, spongy. Does it affect the condition of a tunnel? Unknown. But this is where those specialists really come in, and you wouldn't have thought to bring them with you from day one. Being able to author as well. They do say a picture paints 1,000 words, but what does a 3D immersive model picture? 10,000 words, I don't know, just making up a number, but it really does help to quantify, or not quantify, but to show people, visualize what's happening and what you've seen. Which is key. And as some of the interesting ones as well, which I'll come to later, is some of these websites you can find where there's a bit like BTSYM, a lot of people interested in topics and in tunneling. You often find these interest groups out there, and later on in the slides I'll show you one of those quite random interest groups which you can find a load of niche information on. And with inspecting, you've also got hidden defects, which is a big area now. So you've got Syria's released a hidden defect report on bridges. It is bridges, it's not tunnels, but the theory is still the same. And it's when you're going inspecting, how do you find defects which are not visible? You wouldn't know to look for them. And some non-intrusive testing, it can be done. And we've actually had some success, you could call it luck as well, by plotting all defects in a database, checking them against geology, and really trying to put all data in a single model. Common data environment is, I suppose, he's trying to work towards that as a goal, and trying to analyze them to see, okay, if we match certain defects with certain geology, with certain geohazards, does it identify a location where we should be looking at doing core holes or looking for defects behind the lining? And for Severn Trent, that was, it worked. Say, you could call it lucky, but it did work, and we did identify a series of defects in some of their strategic network by using this technique. James will show you some techniques used recently later on to enable us to bring the asset, the client, contractor and specialist together without additional site visits. So being able to go back and back time and time again into the assets to review the condition of the structure. Next slide, please, James. It's also important for us to understand confined spaces and the regulations we have to work within. And there's on the slide after this, it'll become quite clear why some of these digital techniques we really should be focusing in, not just from a quality of work, but from a safety point of view too. So anybody in the tunneling industry really should start reading the confined space regulation. It's not the most thrilling read, but it's something which really governs us day to day and what we do. New tunnels, you design tunnels to be safe. You hope you've got BS 6164, you've got other standards to follow, but existing tunnels can be very old, 1900s constructed, even pre-1900. So the safety systems which we would expect today are not present. So you do have to manage them differently. The Confined Spaces Act, regulation, has these specified risks, which are listed on the slide here. I won't go through each of them, but basically, if you've got one of these specified risks, it becomes a confined space. And you do need to look out for the fact that certain tasks you're doing inside a tunnel can cause a specified risk to occur. So for James and I, if we're working in a tunnel doing inspections and one of the contractors has come to do some core holes, that can actually add a new specified risk. You've got dust, you've got noise, you've got obstructions. These can be a hazard for us there. People do get prosecuted under the confined space regulations. Before the talk, I did a quick search to see recent prosecutions, and there's an interesting one for a plumber. A plumber doesn't sound that relevant for a tunnel, but he was plumbing some flats in Wales, and there was no ventilation. He brought inside a waterproofing chemical and passed out because the chemical made the atmosphere toxic, and he couldn't breathe because of the ventilation. So even areas you don't expect to be confined spaces can become confined spaces. And that's something I think really important for us to appreciate as we do our work. If you do next slide, please, James. And this is where the digital side starts to come in. So within the regulation, we do have Article 4, prohibit the entry into a confined space for the purpose of carrying out work where it is reasonably practical to carry out the work by other means. So you do have a duty, and everybody has a duty. You as the engineer, your employer sending you in, and the asset owner, the client who owns the asset, to work towards this regulation. And so we do have a duty to at least look to see if there are other methods we could use to inspect. Or just to do the works in the tunnel or confined space. And with regulations, Health and Safety Executive does provide approved code of practice documents, ACOPs. And again, I think everyone should start reading ACOPs and using ACOPs a lot more on work, because they do provide a lot of very common sense guidance to go with regulations and other documents. And Article 72 of the ACOP, examples of modified working practices preventing the need for entry. So it does list a series of, these are potential ways you can limit yourself having to go into one of these confined spaces. And I've picked out Article D and Article E. Article D, use of CCTV, and Article E, remote visual inspection, RVI, to carry out examinations. Big caveat at the end of that, but only if this will provide the same results and safeguards as entry would. And that's the big hurdle I think as an industry we're coming up against, is do these techniques provide the same level as sending humans into that asset? And we'll go into a bit of that as well. But this really links to the classic hierarchy of risk control. There is a risk. You're going into a confined space. Can you eliminate it? Can you substitute it? Trying to aim for those top two. They're the key areas to try and move to. Next slide, please, James. And so this slide shows a series of tunnels. Actually, one of them, the top left, I was trying to find an image. We did some work in London deep sewer inspection work a while back. The photos were on the office hard drive, so I couldn't get to them. But I Googled it and found this website called... what was the name of it? Close Encounters of the Turd Kind, which was a brilliant website name. But you've got a lot of enthusiasts who have been going into sewers, very strange enthusiasts to go into sewers, but there's a load of archive of photos there. So it's not really on the digital side, but it's just if you are doing inspections, you do go to these websites. They're full of fantastic information for us. But the main thing about this slide is actually we do have the regulations to deal with, and they're trying to encourage us to not go into confined spaces where possible. But we've also got the client requirements. Now, clients often have a principal inspection, general inspection, where a general inspection might be every 1 to 2 years, principal inspection maybe 5 to 10. The general rule of thumb with a principal inspection is you are up touching that tunnel or bridge, whatever you're inspecting, with your hand, so you are that close to it. So can these digital techniques replace a principal inspection? Those conversations are happening at the moment. General inspection, yes, I think they can do, and they do at the moment. Principal inspection, it is a bit more tricky, but equally, Network Rail are doing funding with Innovate UK on techniques out there to enable them to do inspections of their tunnels without having to do possessions. And Highways England have had a similar idea with the Transport for London, just did a recent tender, and within the tender they were happy to open up challenges to the principal inspection requirements if people wanted to bring with them new digital techniques which would lower costs. And some of these costs are, so you've got highways tunnel there, traffic management. Traffic management is expensive. You don't want to be closing these assets down. Once it's closed down, that's your window to do your inspection. So you've got to make sure you do that inspection in that window, which again, these digital techniques, which James has gone to, allows you to capture more information within the time frame available, which then potentially allows the principal inspections to be more targeted in the future. Network Rail, again, possessions. You must do your work within the possession time. Sewers are often having a shutdown, so you'll be given a shutdown for, say, 3 days or 2 days, or maybe a few hours, 12 hours to do the inspection work. Water tunnels, very similar. The bottom right is actually a hydropower tunnel. And something hydropower clients come to is, can we do an inspection without turning off the water? I.e., we want to keep making money. How can we inspect and still make money? And these are fair drivers, and something we as an industry do need to start coming up with very clever solutions to enable us to do inspections without having to do the headaches of shutting down and stopping income. Next slide, please, James. And from my point of view, I think this all comes down to risk. Clients will be pushing for these risk-based approach to asset management, and this is excellent. And great rewards will come from this as long as they review, evaluate, assess, plan, analyze, and have a process in place. So all those things on the periphery of risk really need to be in place. The Network Rail, I think, are doing this quite well, and we just need to make sure the other clients don't suddenly see Network Rail jumping from a 10-year PI inspection to a 20-year based on a risk approach, but you really need to have all those methods and mechanisms in place to really do that. And this comes back to those general inspections. I think general inspections, we should be using these digital techniques more and more, enabling us to have more information, do a better desk study to allow us to do a targeted principal inspection when we need to do it. I don't think these digital techniques are going to replace a human have to go in and do inspections, but hopefully we can reduce the requirement or the amount of time they need to go into. There are techniques like automatic change detection, which is quite readily available and relatively simple to use now once you've captured the data. And there's a lot of algorithms around, especially for checking and looking for cracks within photos. Caution needed, the fact that cracking is one of several defects you have to look for when you're inspecting. So we've also got to make sure these digital techniques are not in addition to what clients are currently doing, but they're helping the client achieve their inspection to their current requirements. And I'll pass you on to James to talk about some of our case studies we've been working on.
Thanks, Will. So I think it's probably important to look at what's happening now and in the past before we start looking ahead. I think we'll touch on it a little bit earlier. I think there's nothing more beneficial than actually seeing something in the real world that's tangible, able to be investigated. You can look at it from a variety of angles, maybe poke and prod at it. With that being said, as a second-hand report or even as a reviewer of the inspection, you only ever get one view, and that was what was photographed on the day and presented to you in that report. Now, conventional inspections typically come in the form of a report with an appendix and countless photographs, have no annotation, can sometimes just take more time to decipher than if you just went out and looked at the structure yourself. I can't tell you how many reports I've read from really competent engineers that didn't realise at that moment in time, for the short periods being actually boots on the ground inside the tunnel, inside that possession that Will was talking about, they missed the obvious pictures. And all you needed was look a little bit further down and you'd see the likes of this. Maybe it was even the obvious dimension they missed. Maybe they couldn't reach that dimension. Maybe they needed a scaffold or a mute, for example, or maybe they just missed it because it's just within the time frame. So we looked at this as an approach within Arup, and we attempted to make this process a little bit more streamlined, a little bit more efficient, and we wanted to really deliver a high quality inspection and reporting method that was really easy for somebody to pick up. Now, the only way in our minds to do so is to throw out the rulebook and start from scratch. So let's do a little bit of research. So the future of inspections was a little bit of a clickbaity title, I will admit, but we do have a lot of emerging and proven technology at our fingertips, and we pretty much decided to try out everything on a variety of different projects to try and see what stuck. Now, the first of two systems we'll go through here are point cloud systems, the one on the left being a handheld LiDAR and the one on the right being a static LiDAR system. So first of all, the handheld system on the left-hand side is relatively impressive, actually. I was really impressed with this when we saw it on site. The picture you see is actually taken by myself looking at the iPad that was being live fed the data from a handheld device. This can actually determine where it is using something called SLAM technology. Now, SLAM is just a buzzword, if you will, for looking at a sufficiently different point and determining where it is based on the picture it had previously. So it's quite important here to start with a sufficiently detailed or complex bit of the geometry. We chose the corner on the right-hand side to start our scan. And a scan of this type is used for a really quick, like a low poly, a really simple shape style scanning. And it's really useful if you don't know the general size or the shape of your asset, or if the point density is relatively low as well, to enable a bit of real-time feedback to the iPad that you can see. And you can gain general obstruction. So the cables on the left-hand side of the picture, the freshwater pipe, the red pipe at the ceiling as well, you can kind of get, but the detail really is lost here. Advantage being it takes about 5 minutes to scan 100 meters of tunnel. Now, the second option on the right-hand side is a more conventional static LiDAR system. This can actually be set to different point cloud densities. This is the main system that we've landed on, and we will see this throughout the presentation with the 3D models that we produce at Arup. Now, with regular spacing, every 5 to 10 meters or so, and some key point identifiers, so things with sharp edges or really defining points or colors, you can actually link these scans automatically within a system. You just put it through a post-processing tool, and you can create a full tunnel network in a matter of hours. It's important, however, to continue scans up shafts, or at least to a known tie-in point. So if you're in the middle of a tunnel construction, for example, and you have a total station point that you know, it's important to scan back to that point to be able to geolocate these scans. Otherwise, you just end up with them at 000 point and you don't know which orientation they're supposed to be in. So these kind of scans on the right are typically accurate from anywhere between, I'd say, around 50 to 20 millimeters, which isn't very accurate, but you can get those scans done in about 20 to 30 seconds. And that's the most basic scan you can probably get. I wouldn't advise it. I'd just use one of these handheld scanners. And you get it all the way up to 1 to 2 millimeters for really high detailed scanning that takes about 30 minutes per scan. And if you extrapolate that over every 5 to 10 meters of a tunnel, you can see it quickly scheming up the timescales. So we like to sit somewhere in the middle, around about 4 minutes per scan. Obviously, the more detailed scan, the more time it takes on the site, but also the more time it takes post-processing. You get a much larger file size, a lot more digital noise, and it takes a lot of post-processing time. So you also got to factor that in. Now, both of these techniques form some form of point cloud, whether that be a simple or a more complex one. And you can manipulate this point cloud in CAD. You can create surface meshes. There's also tools to automate surface meshes. And you can create a full 3D BIM CAD model relatively simply. Now, the next digital techniques that we've investigated were surface or immersive imagery technologies, I like to call them sometimes. So photogrammetry can pretty much be captured in a lot of ways. I think Will was mentioned earlier that we actually provided our team, and this is how we got into our digital inspections. We wanted something visual that we could see in a different way. Now, photogrammetry requires some form of imagery, maybe even a video with sufficient overlap. The overlap's actually quite a lot, so around about 50 to 80% overlap you need in your pictures, which is not normal for inspection pictures. And you need to have some key features that the program itself can pull out to stitch these photos together. It seems to be quite a common theme with all of these imagery techniques. You need key features in your tunnel or on your surface, for example. Now, the reason I picked a surface is because we've got two to compare here. So there is a tunnel beneath the road here. We've actually tested this system with anything from mobile phones. We've used GoPros on their own, GoPros in clusters. And we've gone all the way up to that full static LiDAR system that you saw in the previous presentation slide, which takes a full 360-degree imagery. The actual massive advantage with this static LiDAR system, it does take a little bit longer, but it's much, much easier for the system to stitch. And you end up with, one, a colorized point cloud, and two, it's a dimension imagery stitched together. So if you have any anomalous points, you can pull them together a lot more quickly. The second option on the right is arguably a lot better. It's taken in the same location, but this was with a pure surface scanning handheld scanner. This uses a similar SLAM style technology to the Horizon scanner that we saw in the previous with the iPad. This whole scan took me around about 10 minutes. So I just walked around and captured this data, and was really, really useful for VR, for stakeholder engagement, and clients and stakeholders really, really like this kind of immersive technology. This is where this type of system really comes into its own. But a bit of caution here is it's completely inaccurate from any sort of engineering perspective. You shouldn't be taking measurements from the image on the right, but you can take measurements from the image on the left-hand side. It's around about 2 millimeter accuracy. And then the last sort of big ticket method, if you will, is completely remote inspections. We completely excluded humans from the confined space entirely. This is talking about that the top tier of that hierarchy that Will mentioned earlier from the HSC, which is elimination. Now, the video on the right-hand side, if I click play, shows a drone flying down into the tunnel, sort of real time through a surface manhole. And as you can see, the drone provides its own light. It's operated from the surface using a tablet joystick system at the bottom from a pilot. It's small enough to pass through really tight obstacles like this. I'm actually going to pause it here. We were actually intending to drop into these manholes on this project, but the water level was getting really difficult to control. It was coming in just as fast as we were pumping it out. So we sent the drone in just as a scoping tool to identify the problem up ahead, which we actually found here. So a large tree above the tunnel had actually broken through the precast rings and spread inside a flooded tunnel, which allowed a little bit more water. And the water's constantly trickling through this gap in the top and coming in. So this was a big safety moment for us in a lot of our meetings. The image on the left-hand side was actually a photogrammetry model produced by the drone as it flew through. So the drone came through at quite a pace, and just a little bit of post-processing actually created a full point cloud model for us to scale off. Again, not in engineering terms, but it did give us an idea of measurements we had absolutely no business having. So dimensions from the other side of these cable trays that were really important to the contractor at the time. And it really reduced time on site for them at a later date. So a big win for us. So as promised, we're going to go through 2 case studies. The first one here being London Power Tunnels 1 decommissioning. So after the second London Power Tunnels cable tunnels system has been installed, they're getting ready to decommission the old cable network and remove them from the system. Now I chose this project to display as it gives some really good synergy between lots of different disciplines we had in Arup doing lots of different inspections. And it's also kind of our flagship model, if you will, for technical and safety reviews. So we have the task of not only inspecting the substation tunnels, which is this kind of network of lines at the bottom, but also there's 2 substations and part of another building just here. This actually gave us a really good opportunity to be able to interlink all these different scans together and track the HV cables that came from outside of scope all the way through the tunnels, up through the floor slab and into one of the HV buildings. The full sort of 3D stitched model did act very seamlessly because it was all taken with the same scan system, which we'll come on to in a little bit. We found that the cables were actually labeled incorrectly in one of the cases by the contractor, which is a huge benefit. We could show that cable passing straight through the floor slab and up into one of the systems, and we relabeled that for them directly. Now, as Will talked about earlier, we can reduce the amount of people on site. So we require only a skeleton inspection team taking the data asset. We can capture the data and we complete multiple technical, CDM, and all sorts of other reviews in the safety of the office using VR headsets and 3D models, immersive technology. And this actually helped us, 1, reduce costs to the project, which is a massive cost reduction taking experts that we were talking about earlier, but it also improved the quality as we can get 3rd, 4th, 5th opinions from those experts at various angles, different views, and people could really critique each other's views, which was really good, seeing some senior engineers have a conversation. And we actually used the models as our notebook in these meetings. We tagged data, defects, CDM observations directly into these 3D models during our technical reviews. You can see the bits highlighted in yellow and the white text outlets are all the different observations that we made. This actually saves automatically to the cloud. It's backed up on our own servers, so anybody can access the data at any time that's got responsibilities within the project. It even gets pushed to the client directly so they can see it in real time as we're making the observations. And you can click directly onto a defect or an observation in this model, say the orange section just here. And you'll be able to have that exact view that whoever made the observation, you can see it from their exact perspective as the identifier. So you'll be able to see exactly the crack as the person identified it, which is a really powerful system. These images are just going to pop round on a service now, so if you can't see them very well, don't worry. So this is actually the 3D model we created into a 2D PDF. So we used this to create some conventional plan drawings. We use these with CDM hazards, with defect IDs already labeled on. At this stage, because it was our flagship project, one of our first ones, we actually generated a manual task for this project. We didn't have our digital workflow set up at the time, but it was actually still a lot quicker than doing everything manually. So we did have some reference points in here. So there is some advantages, even if you don't have your full workflow set up, just to get ready. It may be too zoomed out on the right-hand plan view just here, but you can actually capture sections directly from the model that we captured here in the outline, and we dropped it straight onto the PDF. So it actually allows the engineer to be quite seamless with the CAD technician as well at the same time, and the BIM technician, which is a huge advantage for us. And it's also really simple and easy to read for the reader. So the client and the contractor in this case, we were on site at the same time. So people are down inside a tunnel in the dirt and with darkness, not a lot of lighting going on there. You don't have to see on the notes page, see drawing X for this, see drawing Y for X. It's all contained on one set of drawings. You know exactly where you are within the tunnel. This was another really cool tool that we used. It's a creation of elevation plots for the tunnel labyrinths that would below another substation I didn't show previously. They're really useful for labyrinths and arrays. We actually transferred understanding of these different aspects. We took this like snippet, turned it into a 3D PDF, and allowed the client and the contractor to have a risk review meeting on their processes. It's really simple, really easy to use, could be manipulated directly by those people in meetings that had no CAD or model experience whatsoever. So this has felt really, really well from the client. And then the last one is just a video just to show how the contractor and also the maintainer, so the operations director there, actually use the LiDAR scans, the asset owner themselves. So it's all hosted on an Arup server, can be accessed anywhere from any device with an internet connection. So you can use it on your phone, on your iPad, at home, in the office, wherever you are. And you can even download the data if you really want to. Obviously, you can't see the live updates, but you can download the data if you're inside the tunnel and don't have a signal, for example. Contractors have used this as a remote site induction tool prior to attending site, which is a really good use of this digital inspections. It's really, really pertinent, especially during the pandemic, to be able to get people out of the site themselves, so you don't have to go to site to have your induction. And as you saw there, you can click directly through to a hazard that's been previously identified. You can create your own dimensions. Dimensions are already saved in there by previous inspectors. And you can actively do these and make observations yourself whilst you're walking around the site with your phone. And when you relink back up to your cloud data, you can push this back to the cloud and everybody else can see it if you've been on site. So there's also quite a lot of scope to identify clash or change detection with subsequent scans. So if you've got, I don't know, a bridge or a tunnel that's technically failing and it's starting to deflect, you can monitor a failure mode of this. If you take multiple scans over every 6 months or so, or however often you need to, you can overlay them and you can show change inside your LiDAR scans, which is a lot easier than trying to take measurements. So the next project burst number 2 is Queen Alexandra Hospital steam tunnels. So these are some ducting tunnels that transfer steam directly from a boiler house to the hospital themselves. And this one was really just to show that these techniques really work well in linear assets as well. This is a lot of questions that we normally get is, okay, it works around a load of labyrinths and corners, but does it work in a long line? And as you can see, this tunnel is very repetitive. There's a very sequential racking system on the left, and there's a very boring right wall. So yeah, you do have to break up the linearity a little bit. The boxes on the floor on the right hand side work to break it up. The debris works. The yellow power outlet cable works. But if you don't have any of these aspects, you can use these Corec kind of globes that for survey control. You stick these through any metal section of the tunnel if you have any. Usually there's a bit of ducting or something in there, or you put them on the floor, and these can help break up the linearity a little bit. The automated assembly tool kind of needs this to be able to combine all of the scans together automatically, which is something we touched on a little bit earlier. And as you can see on the right, the image was actually extracted directly from the online web viewer. So this is really, really good photo quality. It's 360 photos, full HD. The machine we use is around about 4 years old at the minute, Arup own, but brand new scanners, anything from the past 18 months or so. If you're hiring one, it's a little bit more expensive. But it goes all the way up to 4K video, 4K imagery now. So I'd say get a minimum HD. I think that's all they do. But yeah, you got up to 4K if you really need it. And then the next point is probably just linking data together. Trying to link 2 pieces of data like this just really doesn't work. It's the same as taking your extremely detailed sort of 3D blocks analytical model and trying to link it with your 1D line beam in the first instance. The systems just either aren't compatible or often a lot more hassle than it's worth. You don't have any key indicators with that one on the right. And this is another question we normally get is, can you just use the fixed wing static LiDAR system that we've flown a drone at 1,000 feet or something previously and got this really not very detailed point cloud? Can you link it with yours? A lot of times the answer is no, because it's just not detailed enough. Sometimes yes, but a lot of times no. It's just a watch it point. So on this one here itself, Queen Alexandra Hospital, we actually used 2 different types of remote inspections. The tunnel itself was very hot. It was around about 55 degrees ambient temperature inside a steam tunnel. So people access was limited to about 5 to 10 minutes maximum before you started exhibiting signs of heat stress. So we went through a remote access inspection method instead. On the left is the indoor UAV drone that we saw some footage from earlier. It's less than 400 millimeters in diameter. These drones in the hand of a skilled pilot, which we've seen previously on site ourselves, can actually be flown down a smaller gap as 600 millimeter pipe with water in the bottom. So it's very impressive, the small gaps that they can go through. Their range is relatively limited, but they can go up and over obstacles, and they're great at reconnaissance style flights. So range is limited to about 100 meters or so without corners. Now, the next thing is the crawler robot on the right. It's a fixed cable system that can't go over large obstacles like the drone can. But the big advantage this has, it's powered by mains. It never runs out of battery, it never lands itself, never gets caught on anything. And it's definitely a far cry from the old wonky CCTV inspection reports that I've seen in the past. Look like they were filmed from a Mars rover. These systems sort of now come in 4K video. We actually installed one of the Horizon handheld scanner systems on top of this and sent it in for a better LiDAR scan than we could get from the drone, which is a really, really useful tool, actually. And then the last aspect to balance is risk. So these are just two videos. The left one is from the drone's view and the right one is from my view. So as Will talked about earlier in the presentation, the risks are not completely eliminated with unmanned operations. The video shows that we remove the general risk of entry, but we have a permanent record, but you still have to ask yourself some questions. So the first one, the big cables above you. The second one, entrapment risks. Can you get caught in that cabling on the left? There's stuff that can fall on top of it as you go past. There's dust. What hot pipes? What if it runs out of battery? What if it gets stuck? The last big one is the unknown. The drone can only fly so far. So what happens if you lose your signal? These are all normal questions that people ask. I actually put out a LinkedIn post very recently, and everybody wanted to answer to these questions. Now, the big thing is you can't tether it. It throws off the gyroscope. You can't always predict when it's going to lose signal. But what you can do is plan for these eventualities. And it's a hell of a lot less risky for a 5-minute entry to retrieve the drone in the case of an emergency, obviously, so long as you plan it appropriately previously, than it is to spend a 12-hour shift for 3 people inside the tunnel inspecting. So it's all a balance of risk. That's all it is. It's not elimination of risk. It's just a balance. And then finally, for me, there's a huge advantage with some digital workflows over recent times. And as previously I said, it was a bit of a manual process. We've actually automated a lot of our deliverables now. Whilst our clients are still asking for paper drawings, I think it's very obvious that we're going to be moving to sort of digital model delivery, as we showed with previous case studies. But people are really familiar with paper drawings. People like paper drawings. It makes it easier to approve and also to complete quality controls because people understand them, the procedures are there. So why not make the paper drawing better? Why not improve the quality of our submissions? And we can do so through a bit of automation. So now, as we went through previously, we already had that data. We've done those technical reviews. Those reviewers have already come in and tagged exactly in the model where every single defect and every single CDM observation that they've made is. We've gone through countless 3rd, 4th, 5th reviews. So it's already, all the data's there. Let's just drop it directly onto a drawing border. And all we have to do is upload those pictures directly to the cloud that's taken as part of your 3D immersive model, and it drops exactly in the right position for us, already annotated and already labeled. This just takes a few little quirky minor scripts, and you're right there. So I'll hand back over to Will. I'll clear up the rest of the slides.
Thanks, James. No, thanks, James. That's really good. So it's two more slides actually, and I suppose it's just thinking about what is next with some of these. I suppose the digital aspects of inspection, and James did mention it. So some of the contractors did come back and say, "We saw you scanning the tunnel. We want to do some works in that tunnel in the future. Can we use your model now?" They've done their risk assessment method statement within the model and then used it as an induction tool. And just like James said, COVID happened to occur whilst we had some of this data available, and so the contractors were able to get their teams inducted remotely using the information captured. So it does have these hidden benefits for the future as well. I've put the scary word there, digital twin, and none of the stuff we're looking at here is a digital twin, but it's just the idea that as you're collecting this data, you are enabling yourself to start having multiple teams looking in that common data environment. You've got the defects, the M&E teams will come and start tagging in their pipelines, and then they may want to ask about installing a new pipe, a new electric cable, and they'll start using the model to input their data. So we're starting to step towards that common data environment, which is great, to be honest with you. And it's one of those steps towards the higher BIM maturity levels. We have had questions about, can we tag the light bulbs with different types of, this one's 100 watt, it needs to change in X many years time, which is coming on to 6D BIM. Ironically, I'm skipping all the other steps, but it is an enabler for these higher levels, which I think is something we do need to be pushing. and capturing the data labels the clients, the contractors, the consultants to have that data to move and work on. As a bit of CPD for everyone, it is probably worth people, especially those pre-charters who want to get some good CPD, to read the UK Digital Strategy, the PAS 180 and the PAS 181. It goes through some really good ideas on this, and it's based on cities, but it's really a good idea on this digital techniques, digital technology. How can we use them in the future? And it does make you think about your current projects and how you may want to do something slightly different or use the data you've got in a different way. Next slide, please, James. This is the final slide, and it's really just an interesting point. The fact that we've been talking about this Faro scanner on the left-hand side there. We've got the GeoSlam, the handheld one. But then iPhone's just brought out, we don't have shares with Apple, but we will sell their product today. And the fact that they've got a LiDAR scanner on the iPhone 12 Pro and the iPad Pro. Now, is it a gimmicky thing? It may well be, but people have used it and shown output. And in fairness, it looks quite good. But it's not a professional LiDAR scanner, and it's not meant to be one. But everybody on site carries an iPhone, and that's something about photogrammetry. You can do photogrammetry just with an iPhone camera. It's not as good as a digital SLR. You can now do LiDAR with an iPhone. It's not as good as a stationary terrestrial LiDAR, but it enables the mass people on site to start collecting data better. And so hopefully in the future, we'll go to the point where people on site will see an issue, and instead of taking a random still image, they could now take a small LiDAR scan, several images, do photogrammetry, and you've got the point cloud model, send it off to the clients or their bosses or consultants and ask for assistance with it. And I think this is really interesting, the fact that there's a lot of small, cheaper technology coming to the market soon. I know the iPhone's about £1,000, but it is cheaper technology compared to a £50,000 LiDAR scanner. And it'll be interesting to see how we're going to start embracing a lot of this technology going forwards to help us with kind of inspections and making more informed decisions, I suppose, is the key bit. Next slide, which I think is the end. Thanks, James.
Yep, so back over to you, Divik. I think to field any questions, if that's okay, if anybody has any. Happy to answer.
Hi, James. I can see two questions on the side there. Can you see those two, James?
Oh, yes, I think so.
So you got them. How big is the tunnel pipe that you flew? Oh, it's disappeared now. I think the question was, how big is the tunnel pipe you flew the drone through? James, do you know the answer to that one?
Yeah. So the first one that had the cable in there, that the dewatering system was 1.2 meter diameter. It was interesting actually that the cable system, the cable network, we estimated from the LiDAR scan took up around about 72% of the cross section of the tunnel. So if you think of a person entry, I think it's almost impossible. You'd be on a horizontal slope, pretty much. Vertical slope, sorry. The next one is, what is the approximate time cost of processing your point cloud data and the file size in terms of handling lag with our standard mobile tablet devices with internet generally available at site? So I haven't found a huge issue with the internet site. So once it's up and running on the web cloud, it's a relatively low use rate of bit rate. You can actually download the core model to your phone or your tablet originally, and then you can only have the updates come through, or you can download the full system and wait until you get back into a Wi-Fi position, for example, to push the information back. Now, the approximate time of processing your point cloud is really dependent on how big your point cloud is. It can be anything from a couple of hours, if all goes smoothly, you just push it through, to possibly 2 weeks, 3 weeks, if you have a really detailed, high density, really big model. So I hate giving an answer like that. I'm really sorry. But if you've got something, for example, the one that we had, the base tunnel geometry, the first London Power tunnels, and also the three substations, this took around about a week to process because it was a colorized point cloud that's relatively detailed.
Yep, that's a fair point. And it's always the case. The way the surveyors often work is they'll push the data through and it'll come back with X many errors. And so you get a base model very quickly. But then to get your accuracy down to those millimeter accuracy is what you may be after. Does take that manual time afterwards. So there is a manual bit to it, which James says can take time afterwards. Traditionally, they also process it on site on their laptop and then upload later on to the web portal, if at all possible.
Yeah. There's also a big thing with digital noise as well. So if you're on a busy highway, for example, or if you're in something that a lot on site and lots of people are moving around, you might find a lot of ghosting in your model, and it sometimes takes a little bit longer to get rid of that ghosting.
Two questions similar on hard drive space. So it is it's a very good question, and I don't know the question top of my head. It is gigabytes. It's not terabytes from my memory, James. You're talking about hundreds of gigabytes of file size, and we do post them to clients on hard drives. Obviously, without file share doesn't work for these type of files.
So we're in for a simple tunnel, 50 meters long or so, 2-meter diameter. It was around about 5 gig. For the big tunnel network, is around about 50-60 gig that we saw with the substations. So yeah, it's not massive. It's big, but not stupidly big.
And that does come back to processing time. So we did play about with the level of detail for the scans, and what we are finding for the inspection purposes, it's actually the imagery becomes more important than the actual point cloud. And there was a couple of scans, I remember, James, where they put it on the super powerful LiDAR setting, which took about 20 minutes to do a single scan. Now, we stick it more on the 5-6 minute scan, which gives them a cruder mesh, but it's all you need for the inspection point of view, for a general inspection. Coming back to that principal inspection problem, that's an unknown. What level of detail would you have to stick your LiDAR scanner on to get the level of detail for a principal inspection?
Yeah, it's probably not feasible. I think principal inspections, you almost have to do your hammer tests. You have to do some form of intrusive surveys and things. So
comparing the cost, yes. So we deliberately did this so it's cheaper. So that was where we set out for, was to make sure that this technique was cheaper than doing a conventional inspection. And that's been, yes, but that did take a bit of time to get that model right in terms of number of people on site recording defects and people capturing the data. So we do have a system set up with a couple of inspectors, usually James and myself, and people capturing the data behind us. So we've got a kind of a dual system happening.
Yeah, there was a question from Matthew as well. So how often do you get unusable data from the LiDAR scan? Yeah, so as Will said before, a lot of times if the scans are small enough at the lunch break and then just after you almost are ready to finish, we'll process the scans on your laptop while you're on site. And a lot of times we can go back in a second day, for example, or if it's we haven't actually had a case where it's completely unusable yet. So we have had one set of corrupt data, and it tends to be the photos that corrupt on the static LiDAR. If they do at all. So we've had 3 times corruption, and only one of those cases have we taken it back to the office corrupted. But the LiDAR itself is usually quite usable, so you can still get your dimensions and things from. And because, as Will said, we supplement it with a visual inspection at the same time, taking generic photos, we can a lot of times fill in those gaps. What's the next one? Andrew, can LiDAR data base point clouds be reduced to lower polygon shell models? How often is the full clouds preserved? So yeah, that's one of the main things that we do, is actually break that LiDAR system down into a usable CAD format so that we can turn it into a low poly as a shell model. There are some automated systems that do this, some better than others. You can write your own scripts if you do Grasshopper or Python, for example, and we use the full point cloud a lot of times just in the online system. So you'll have the viewer, and we'll just use the full point cloud in the online system, or if we need a reference to go back to. Martin Knight's percentage cost difference.
That's a tricky one.
My head, Will. Yeah,
it's a tricky
varies,
one.
I think
it varies. So I suppose the idea would be, say, its maximum would be the same. How it could be cheaper percentage-wise, I suppose we've not actually checked that, but it's always been the same as if, because we often at our bid review internal process, we have to prove why we're doing this as well. Comes back to that confined space, removing risk, but also is it cheaper? So we do often do the comparison, but it's usually shown as just same. I suppose we don't have a value for percentage cheaper off the top of my head. Sorry.
Yeah, and I mean a lot of times at the moment clients have it set up so that it's very competitive to have an inspection and a survey cost, and it's well known in the industry how much each one of these costs. And typically we don't like to lowball anyone. So a lot of times what happens is we just improve the quality. So as we said before, you've got more reviews, you have a bit more detail, and we do it for a similar cost and just improve the quality of the outputs. Asil, thanks for your answers. Generic photos are the only means to verify the digital point cloud data, or are there other means as well? No, so you can do traditional survey control. So if you want to use a total station to get your standard GPS, we still supplement with normal dimension means at the moment. So because we've not completely proved and tested, we're almost doing the conventional inspection as a little bit of a skeleton at the same time as doing the LiDAR scan. So we leave the LiDAR scan to run, for example, walk off and do a bit of inspection and come back. We will get to the point where we should be able to not have to verify the digital point cloud because we have a good case study history, but we're not at that point yet because we're still investigating. It's a good question, Azil. Thanks. Did we manage to get to the bottom, or is there a scroll bar?
I think those are the only questions so far. So just a quick reminder to those present, if you want to ask any further questions, please ask them now. We've got one from David, I think.
Okay.
So David Ashworth asks, could you expand more on how digital workflow you referred to has developed?
Sure. Yeah. So essentially, at the start, what we were trying to do was get a digital capture technique. So we identified all the different techniques that we could use, and the aim was to get a LiDAR scan that was colorized with photos to be able to present a 2D PDF drawing. This kind of later developed on into being a model delivery. So we had to go a little bit higher quality in the LiDAR scan and also the photogrammetry to be able to send a model on a web cloud. We then realized there's a lot of manual processes between all of those systems. So the first manual process is taking as-built or existing information and turning it into a model. You can do that a couple of ways. The first way is with a really low poly. So if you want to walk around with your GeoSlam, for example, come back out and you get a 3D model in the first instance, then you can tag it. The second way is just to do a full 3D LiDAR scan like we have with the static scanner and see what you get at the other end. And then the main difference is the post-processing. So taking that 3D point cloud and turning it into a final either 2D drawing or a usable 3D model was the key for us. Now the usable 3D model is really key because it turns it into BIM accessibility that we was talking about, going up to 6D BIM. That's what clients are really looking for at the moment. But turning it into that 2D plan, we wanted to present a model and have the plan just drop out the back end. So we've essentially automated the entire workflow from receiving a 3D model from your LiDAR specialist to dropping out a 2D plan that just needs a final QA process, and then really focusing on that fourth or fifth dimension BIM model. So that's the way we developed the workflow. I'm not going to give away all of our secrets because then it gives away all of our costing. But yeah.
£5 and we'll give them away.
But yeah, there's a lot of digitization in the post processing. We'll say that much. So it goes through that way.
Fantastic. I think, being mindful of the time, we should bring the Q&A session to a wrap now. So once again, James and Will, thanks a lot for sharing your experience with us today. And once again, thanks a lot to Wojciech for his brilliant chairmanship over the past 1 year. Before we wrap up, I do have a few announcements to make. So first one, next Thursday, which is the 12th of November, BTS will be hosting their Harding Memorial Lecture for this year. The speaker for the lecture is Keith Barbers, who's very well known in the British tunneling industry, and he'll be talking about tunneling in a changing world. Next one on the list, just a reminder, please follow us on social media platforms so that you can stay up to date with our activities and upcoming events. You can also scan the QR code on your screen and end up on a Linktree page, which will give you links to upcoming lectures and other relevant information. You can also send an email to our honorary secretary at the email address provided below and join our mailing list. Another reminder, please do subscribe to our YouTube channel. This is predominantly where we've been delivering the lectures throughout the course of the ongoing pandemic. So please do show us some appreciation by subscribing, and that's another way to not miss out on any future lectures. So on that note, that's all from our side, and once again, a great thanks to Will and James.